in the last video where we generalized the linear consumption function. I said that the total amount of taxes, the aggregate taxes, are constant. All of these were constant right here, and so you can kind of merge them into a constant that ended up being our independent variable intercept right over here. But YouTube user Nilsor1337 asks a very interesting and good question. Well, aren't taxes in some way a function of aggregate income? In most modern economies, people pay a percentage of their income, or in general, the tax base grows as aggregate income or as GDP grows. So is it appropriate to make this constant? So the simple answer is it depends on how carefully you want to model it. In some cases, you might just say, well, no, let's just assume that this is a bulk tax. We're just trying to understand one aspect of it. And you will see that in some economics courses or some economics textbooks. The other way is you could actually model it a little bit more realistic. You could say, hey, taxes really are a function of aggregate income. We could say that T really is going to be equal to some tax rate, I'll write that as a lowercase t, times aggregate income. And in a place like the US, this might be close to the 30% of aggregate income or 20%, whatever it might be of aggregate income is what is going to go for taxes. And if you do it this way and you substitute back into this, you can actually get an expression for consumption in terms of aggregate income that takes into consideration the idea that taxes are a function of aggregate income. And just to do that algebraically, we can rewrite this expression up here. So you have consumption, aggregate consumption is equal to my marginal propensity to consume times aggregate income plus autonomous consumption, the amount that would be consumed no matter what, minus the marginal propensity to consume shows up again. And then instead of writing t right over here, I'm going to write lowercase t times y. So the tax rate times aggregate income. So times the tax rate times aggregate income. So I just took this, instead of writing uppercase t, I wrote lowercase t times aggregate income, and they should be the same thing. But now we've expressed t as a function of aggregate income. And now we can merge both of these. These are something times aggregate income. So we can combine those two terms. So this one and this one right over here. If we factor out a common factor of c1 times y, we get, let me write it this way. Actually, let me just combine them first so that the algebra doesn't confuse you. So we get c is equal to c1 times y. So marginal propensity to consume times aggregate income. Now I'm going to write this one minus the marginal propensity to consume times, I'll switch the order here. Well, let me not switch the order. Times the tax rate, not just the aggregate total tax value, but the actual tax rate, times aggregate income. So that's those two terms there. And then we're just left with the autonomous consumption. So plus the autonomous consumption. And now over here we have a common factor of, we can factor out a c1 and the y, or essentially the marginal propensity to consume and the aggregate income. And so this is just algebraic manipulation right over here. We get aggregate consumption is equal to, let's see, we could write this as c1 times 1 minus t times y. And you can multiply this out to verify. If you multiply it all out, then the first term is c1. So c1 times 1 times y is this right over here. And c1 times negative t times y is this term right over here. And then you are left with your autonomous consumption. And this actually makes a lot of sense, because when you write it like this, you can look at this term right over here. What is this term right over here? Well, 1 minus the tax rate times aggregate income. If the tax rate is 30%, then this 1 minus 30% is going to be 70%. 70% times aggregate income, that's essentially what people get in their pockets. This whole term right over here is essentially disposable income. Disposable income right over here. So we could actually, if we wanted to write this as some other variable, we could just put that variable right over there and say it's disposable income. And then it actually becomes a very simple thing to graph. So we could graph this two different ways. If we wanted to write it a function of aggregate income, we would graph it like this. Now, when we express it this way, taxes as a function of aggregate income, now our vertical intercept, so this is aggregate consumption, our vertical intercept is this term right over here, so that is C naught, and our slope is all of this business. And so the slope of our line, the slope is going to be C1 times 1 minus T. And this right over here, the independent variable is aggregate income. Another option, we could set some other variable to say, well, we could say disposable income. Let me call it y disposable is equal to 1 minus T times y. And then we could write this, so it's essentially equal to this business right over there. So then we can rewrite the consumption function as aggregate consumption is equal to the marginal propensity to consume times disposable income plus some level of autonomous consumption plus some level of autonomous consumption. And this actually takes us back to the basics. This takes us back to our very original situation here, where we had some autonomous consumption plus our marginal propensity to consume times disposable income. And if we wanted to plot it this way as a function of disposable income, not aggregate income, then it would look like this. So this is consumption, and now this is an aggregate income. This is disposable income. Disposable income, which is the same thing as 1 minus the tax rate times aggregate income. Now, still our vertical intercept is C naught, and our line's slope is the marginal propensity to consume. So this is C1, just like that. So all of these are completely valid consumption functions, and I thank Nilsor 1337 for bringing up a topic that actually was a cause of confusion for me, because it really does depend, because I thought the way he or she originally thought about the problem is like, well, taxes are a function, and a lot of econ books tend to treat this as a constant. And that is actually just an assumption they make to often simplify the calculations. But if they don't want to make that assumption, you can still show that it is a linear function of that aggregate consumption is still a linear function of aggregate income.